Alright guys, here we go. We're going to do an example of a uniform circular motion question. So we're on page 170 and we're looking at number 60. And I'll include that problem in the video description here. Alright, so I'm reading it for you. An athlete whirls a 7-kilogram hammer. So again, right off the bat, I'm always writing down what we're given. Mass is 7 kilograms. An athlete whirls a 7-kilogram hammer 1.8 meters from the axis of rotation. Okay. So we got our athlete, we have a radius of 1.8 meters, and we got a really ugly circle with a radius of 1.8 meters, and the hammer makes 1 revolution in 1 second. So 1 revolution per second. What is the centripetal acceleration? So A sub C. And if we remember our formula there, that's equal to V squared over R. And we also want to know, it says the tension. If you remember, tension is a force, so that's going to be your force centripetal. And that's equal to MA, if you remember from previous chapters. Okay, so to find our centripetal acceleration, we need to find how fast this hammer is rotating in the circle. And so we know it takes 1 second for a complete rotation, and so using our basic velocity equals distance divided by time, we need that distance, right? And so we know that circumference is the distance it travels, right? 1 complete circle here is how far that's going, and that's 2 pi r, which is equal to 2 times pi times 1.8, and so I'm going to call that 1.8 times 2, mental math, 3.6 meters. Alright, oh sorry, 3.6 pi, 2 times 1.8 is 3.6, but we still have that pi in there. 3.6 pi meters. Okay, so 3.6 pi meters divided by 1 second is 3.6 pi meters per second. Alright, so that's our velocity. Alright, we're almost done. These problems are pretty easy. So our next formula, oh Jesus. So again, our centripetal acceleration is equal to velocity squared divided by the radius. So that's going to be 3.6 times pi squared divided by 1.8, 3.6 times 3.14 squared divided by 1.8. 70.98 meters per second squared. Cool. So that's our first answer. Our centripetal acceleration is 70.98 meters per second squared. Now we need to find the force. So our centripetal force is equal to mass times acceleration. We have our mass. It was given to us as 7 kilograms. So that's 7 kilograms times our acceleration, which is 70.98 meters per second squared. And seven times 70.98. So that gives us our centripetal force is 496 newtons. Alright. That's it, and that's all. So our answer is 496 newtons and 70.98 meters per second squared for our centripetal acceleration and our tension, which is the centripetal force in this case. Onwards.